Okay, for section 3.6, there's not much to talk about through the examples. For some reason, the textbook loaded the examples with word problems, and then they didn't put any of those in the problem set. So I just kind of summed up what they did with my own little methods here, and you can pause it if you want to. I'm not going to talk about all this and bore you with it because it doesn't really matter to our problems that we are going to do. For the problems we are going to do, I would start here in my class lecture. Example 7 says if function f is given by these pairs. Now, in chapter 3, just keep thinking ordered pair, ordered pair, ordered pair. When you see this, you know there's an x, a y, x, y, x, y, x, y. So the whole idea of function is when you see f of x, then x is whatever your x value is. And here I have an x, which is -2. Here I have an x that's 3. Here I have an x that's 2, an x that's 7. And in this particular case, it means that when x is -2, whatever my expression is will equal 0 for y. That was a solution. If I plugged -2 in for x, I end up with 0 for y. Here, if I plugged 3 in for x, I ended up with -1 for y. So if function f is given by, I think I went ahead here. They give us f of -2, I'm guessing. And if we see f of -2, we just look for where was -2. Here, that means it would be 0. My output would be 0. My y would be 0. The whole function would be 0. Remember, f of x basically replaces y the way you've been learning. You've been learning y equals mx plus b. Well, now instead of y, we're saying f of x. Instead of throwing two variables in, we're saying, let's just say y is a function. It's a function of x, f of x. Then you only deal with one variable. So again, here, what happens when f is 3? Well, my y is -1. That means function of x when x is 3 is -1. F of 2, well, my y is 4. That's all you do for that. Always think x is x and f of x is y. And then I'm not going to work through this one. You can look at it because I'll just work through one from the problem set or set. So problem set 3.6. Let f of x, function of x. Remember, this is the same thing as a line that's y equals 2x minus 5. They're just writing it different, introducing us to a new way to write. A lot of math, a lot of what we're learning is how can we write it in simple terms and symbols instead of wording it all out. So they're showing us step by step how they've turned y equals 2x minus 5 into a function of x. So when you see this, all you have to think, don't overcomplicate this. It looks a lot worse than it is. All you have to think is that x replaces that x. F of some x equals all of this. And it doesn't matter how many x's you have here. Once they give you a value for x, you just plug it in wherever you see an x. So here, they're saying a plus 6. What that means is now my x has become a plus 6. This is just for let f of x equal this. Evaluate f of a plus 6. It just means now take this x and make it this. So anywhere you see the x, you replace it with this. So I'm trying to think of the easiest way. I'm going to go vertical. I had f of x is 2x minus 5. Well, my f of a plus 6 then is 2 times a plus 6 minus 5. So my x became what they gave me. It doesn't matter there's a different variable. It doesn't matter how much is here. They could give us 15 terms if they want. And they could say, hey, it's no longer f of x. It's f of all these 15 different things. and I would plug it in for x. This -5 is just along for the ride. The x is attached with the 2. So I made my x an a plus 6. Everywhere I see an x, I make it a plus 6. So then I just expand, or I distribute. Instead of 2 times x, I know my x is a plus 6 now. So it's 2 times a plus 6. 2a plus 12 minus 5 equals 2a plus 7. That's it. That's my answer. I can't do any more. There is no equals. We're just rewriting it, supposing that instead of x, it's now a plus 6. So 2a plus 7. Now 19 looks a little bit different. They give us a fraction. No big deal. Just you know that this, I should have written it a little cleaner. You know that x became 1/2. So anywhere I see an x, I write a 1/2. No longer x, my x is x. So I can do this. I can say, well, x is x. But if x becomes 1/2, then that's my new x. So 2 times 1/2, g of 1/2 instead of g of x. Everywhere I see an x, they could give me a lot of them. Everywhere I see an x, I just plug in 1/2. And the 2's cancel out. I'm left with 1 minus 1 equals 0. Now 37. Same concept. You just have to do 2 steps. Well, I shouldn't say 2 steps, but an extra step. You have to solve one function and then solve the next function. So what we have is f of x. So f of x is this whole thing. Then g of x, let me write it down here. Well, no, here, I'll put it up here. F of x equals x squared minus 2x. What they're doing now is they're saying, well, my x is now g of 3. My x is g of 3. Well, I have to figure out what g of 3 is first. Then I can plug that in. So g of 3, I don't know. I have to solve it. Once I solve it, then I plug it in for x. So g of x is 5x minus 4. If g of x is 5x minus 4, g of 3 is 5 times 3 minus 4. I'll put it over here. So g of 3 equals 11. I'll write it right here. When I plug 3 in for g of x was 5x minus 4. That means g of 3 is 5 times 3 minus 4. That means g of 3 equals 11. Well, now I should do this. I just found g of 3 is 11. I plug that in for my f of x. F of x here became f of g3. I solved g of 3, got 11. Now I know that's what g of 3 is 11. So I plug it in. So now I go back to my fx, x squared minus 2x. Everywhere I see an x, it's an 11. So instead of x squared, I have 11 squared. Minus 2 times, instead of x, I have 11. So I have 121 minus 22. This one actually worked out, because I had numbers to deal with, worked out to an even number. Well, not even, but I mean a solid whole number, not a variable like the top one. So that's step by step how we work functions when they give it to us. And we'll jump from here to 3.7. We'll just learn how to start, or 3.8. We'll jump to 3.8, and we'll learn how to do some algebra with this stuff. So we'll use these concepts and start combining more. Okay, hope you had fun. I think it was a blast.